Hey, what's up guys? Welcome to another video. In this video I'll be going through an A-level mathematics paper. This is a sample assessment made by Edexcel, which is available for free from the Edexcel website, so I'll leave a link to that in the description so you can go ahead and download that paper and have a go yourself. Obviously have a go before you watch any of this video. With the new A-level specification, now all of the assessment is done by examination, external assessment, and after the 2 years you'll sit 3 papers. This is the first paper, paper 1, Pure Mathematics 1. The second paper is also a pure mathematics paper, and the third one is statistics and mechanics. So in this video I'll be going through this Pure Mathematics 1 paper. This is for the Edexcel exam board. You're given 2 hours to finish this exam, and you're allowed a calculator along with all of the other usual equipment. And I'm sure you've noticed by now this video is over 2 hours long. I did think about splitting it up, but I thought you can obviously always skip through the video, so I think it's easier for everyone if I just put it all in one place. Just one more thing, if you're a GCSE student about to start A-levels, this could be useful for you if you want to have a look at the type of content that will be covered in A-level mathematics, and of course this is useful for you if you're revising for your A-level exams coming up. So I think that was everything. Let's get straight into the questions. Question 1 says the curve C has equation y equals 3x to the power 4 minus 8x cubed minus 3, and part 1 asks us to find the derivative and the second derivative. So let's just do part I first. So the derivative of this equation, we can just use the power rule for each term. So take the power, bring it down the front so it turns into the coefficient, and then subtract 1 from the power. So if we bring that 4 down to the front of this term, we'll have 3 times 4, which is 12. And then we subtract 1 from 4 to get the power, so we get 12x cubed. Do the same thing for 8x cubed, so we'll get 3 times 8, which is 24. And then subtract 1 from 3, so that's x squared. So that's the first derivative. And then for the second derivative, we can just use the power rule again. So that 3 comes down the front, so 3 times 12, that's 36 x squared, and then do the same thing for 24x squared, and that will be 48x. So all we need there is the power rule. Part B says verify that C has a stationary point when x equals 2. Remember, a stationary point is when the gradient is 0. So we could state that. You probably don't need to state that, but just to be clear, a stationary point is when the gradient equals 0. And well, we know that the derivative is the gradient of the curve. So if we substitute 2 into this derivative and it comes out to be 0, then we will have verified that there's a stationary point at x equals 2. So let's take x equal to 2 and plug that into the derivative. So 12 times 2 cubed minus 24 times 2 squared. This is going to be 12 times 8, that's 96. And 24 times 4, that's 96 as well. 96 minus 96 is 0. That's probably enough, but you could also make a statement. So as dy on dx equals 0, there is a stationary point. You could just leave the working out, and I'm sure that would be enough for 2 marks, but if you want to make a statement as well, that would be fine. Part C says determine the nature of this stationary point, giving a reason for your answer. So the nature of the point is basically saying, is it a maximum or a minimum? So if we're talking about a curve, it goes up and down, and if the point is up here, right, if it's a maximum, the gradient is a 0, and if it's a minimum, the gradient is a 0. And they're asking us, well, is this point a maximum or a minimum? And if it's on the top of a curve, then what's happening to the slope of the curve? It's going from positive to negative, right? So if we took a tangent at this point, we took a tangent at that point there, that would be a positive slope, and then if we took a tangent at this point, it would be a negative slope. And then if it's a minimum, the slope is getting more positive. And remember that the second derivative is giving us the change in the slope of the tangent. So depending on the value of the second derivative, that will tell us the nature of the stationary point. So we can find the value of the second derivative at x equals 2. So when x equals 2, the second derivative will equal 36 times 4 minus 48 times 2. 36 times 4, that's 144, and 48 times 2, that's 96. 144 minus 96, that is 48. So that's clearly a positive number. So the second derivative is positive, meaning that the slope is going from a negative to a positive. So this stationary point must be a minimum. So we can say as the second derivative is positive, the stationary point is a local minimum. Okay, so that's question 1 for a total of 7 marks. On to question 2. Question 2 gives us a figure and it says the shape ABCDOA as shown in figure 1 consists of a sector COD of a circle center 0 joined to a sector AOB of a different circle also center 0. Given that arc length CD equals 3 centimeters, angle COD equals 0.4 radians, and AOD is a straight line of length 12 centimeters, find the length of OD. And then part B says find the area of the shaded sector AOB. So firstly we need to find the length of this line here, OD. So this is where you notice the clear difference between GCSEs and A-levels, the step up in quality. We rarely use degrees anymore, we prefer to use radians, so we have angles in radians. And remember what this means. So 0.4 radians means this length, this arc, is 0.4 of the length of the radius of the circle. Right, that's the definition of a radian. You get 1 radian when you wrap the radius of the circle around the outside of the circle, and that angle that forms will be 1 radian. So if this is 0.4, that means this arc length must be 0.4 of the length of the radius. So that allows us to work out the length of OD, which is the radius of this circle. So we can say that the arc length equals 0.4 times the radius. And we know the arc length is 3 centimeters. So we can say 3 equals 0.4 times R, and that allows us to work out R, or OD. So therefore, let's just leave it as R for a minute to be clear. So 3 divided by 0.4 gives us 7.5 centimeters. So R in this case was OD. So OD equals 7.5 centimeters. And part B asks us to find the area of the shaded sector AOB. Right, so the first thing I want to do is to work out AO. Now that I have OD and I know this whole length is 12 centimeters, AO will be 12 minus 7.5, which is 4.5 centimeters. The other thing I can work out is this angle in here. So we know that if we're talking in radians, the angles on a straight line equals pi. In GCSEs we would say 180 degrees, but if we're talking about radians, that will be pi radians on a straight line. So that angle AOB will be pi minus 0.4. So this one, pi minus 0.4. And now I have the radius AO and the angle. I can work out the area of that sector using the area of a sector formula. So area of a sector. Now the area of a sector, if you're talking about radians, it's just the angle times the radius squared divided by 2. It's a bit different if you're talking about degrees, but if it's radians then it's a bit more simple. So we can take that angle, which is pi minus 0.4 times r squared. R was 4.5. And divide that by 2. And then we could just put that into a calculator. So we've got pi minus, probably should use brackets, pi minus 0.4 multiplied by 4.5 squared and divide that by 2, and we get 27.759. 27.759. Let's double check that. Yep. And it didn't give us a degree of accuracy, so we could just round that off to 2 decimal places, 27.76 centimeters squared. And that question was for 3 marks. Question 3 says a circle C has equation x squared plus y squared minus 4x plus 10y equals k, where k is a constant. Part A says find the coordinates of the center of C, and then part B says state the range of possible values for k. Right, so for part A, we need to be familiar with the general equation for a circle. So the general equation for a circle looks like this, where you've got x minus h squared plus y minus k squared equals r squared. Now, the x and y, they're just your regular variables in the equation. H and k are the center of the circle, so the coordinates of the center are h and k in this equation, and r is the radius. So that's the general equation of a circle, and we need to work with this a little bit to get that in the form of x minus something all squared plus y minus something all squared equals the radius squared. So we need to do a bit of rearranging with this formula. So firstly, I'll group the variables together. So I've got x squared and minus 4x. And then I have plus y squared plus 10y equals k. And now what we need to do is to use completing the square to get this in the form of this general equation. If we use the completing the square method, we'll end up with x minus something squared, plus or minus some number, and then we'll have the same thing for y. And then we'll be able to get rid of those numbers over to the right hand side. If you remember how to complete the square, you basically take half the value of the coefficient of x here, and that becomes your number inside the brackets. And then you expand those brackets out again and find the number that you've got at the end. So if you expanded these out, you'd get x squared minus 4x plus 4. So now you have a plus 4 that you didn't have before. So if I want to write this as x minus 2 squared, I have to subtract a 4 to still make this equation equal the same thing. So this is going to be x minus 2 squared minus 4. And we need to do the same thing for y, so this will be y plus 5 squared. 5 squared is 25, so I need to subtract 25. And all of that equals k. Alright, so we have this now in the form of x minus something squared plus y plus something squared equals a number. And it almost looks like this. I just need to get rid of this minus 4 and this minus 25, so I'll add them to the other side. So therefore this becomes x minus 2 squared plus y plus 5 squared equals k plus 29. Alright, so that looks pretty much identical to the general equation of a circle, and using this equation I can read off the center, the coordinates of the center. So the coordinates of the center will be, remember, if it's a minus, then the coordinate is a plus. In the general equation we have x minus h squared, and therefore h is the coordinate. So here we have x minus 2 squared, so therefore 2 is the x coordinate. And here we have a plus, so the coordinate will be a negative 5. Okay, so we've answered part A. Part B says state the range of possible values for k. So this question requires you to think critically about the radius of a circle. What's the minimum value of a radius? Well, it can't be anything less than 0. You can't have a negative radius of a circle because then you won't have a circle. So this value here, k plus 29, must be greater than 0. So that's how we can start. We can say k plus 29 must be greater than 0. So therefore, k must be greater than minus 29. We could also add a bit of reasoning here. We could say as the radius can't be negative, but that's about it really. You don't really need to explain too much. Okay, so total of 4 marks for question 3. Part 4 says given that a is a positive constant and the integral of a to 2a of t plus 1 over t dt equals the log of 7, show that a equals the log of k where k is a constant to be found. Right, where to start with this problem? Well, firstly, let's start looking at this integral. So the integral of t plus 1 over t with respect to t, let's see if we can find what that is first. So this is going to work out easier if we actually split this fraction up into 2 pieces. So if we split it up into t divided by t plus 1 on t, that's going to be slightly easier than trying to work out t plus 1 on t, where we'd have to use the quotient rule, probably. But in this case, t on t is just 1, so we're looking at the integral of 1 plus 1 on t dt. The integral of 1 is just t, and the integral of 1 on t, that is the natural log of t. So this is going to be t plus log of t, and then make sure to add that constant on the end. Right, so that's your first step, finding what this integral actually equals, and then we need to use the fundamental theorem to find the value of the integral from a to 2a. So now we need this value of this integral from a to 2a, and this is the notation we usually use, and we're also told, remember, that this equals the log of 7. So we can stick that in now, so this will be the log of 7. I didn't use that up here just because I was looking for this integral, but now we can turn this into an equation where this integral equals the log of 7, and to find the interval we need to substitute 2a into this and then substitute a and subtract them. So 2a into this will be 2a plus the log of 2a, and we need to subtract a plus the log of a, and that equals the log of 7. And then I'll subtract these two things, so 2a minus a, well that's just a, and then we have the log of 2a minus the log of a, and this equals the log of 7. Now remember your log rules. When we have the log of something minus the log of something else, this can be written as the log of those two things divided by each other. So remember, that's the power of logs. It turns division and multiplication into addition and subtraction. So log of 2a minus the log of a can be written as the log of 2a divided by a. And looking at this 2a divided by a, those a's will cancel out. So we're just left with the log of 2. Alright, so this log of 2a minus log of a can be written as log of 2. So on the next line we end up with a plus log of 2 equals the log of 7. And if we subtract that log from the right hand side, we'll get a equals log of 7 minus the log of 2. And again we can use this idea. This turns into a division, so a equals the log of 7 on 2. And look back at the question, it's saying show that a equals ln k where k is a constant to be found. In this case, k is going to equal 7 on 2. And that is question 4 for 4 marks. Question 5 says a curve C has parametric equations x equals 2t minus 1, y equals 4t minus 7 plus 3 on t, where t does not equal 0. Show that the Cartesian equation of the curve C can be written in the form y equals 2x squared plus ax plus b divided by x plus 1, where x does not equal minus 1, where a and b are integers to be found. So the first thing we want to do here is to take these parametric equations and substitute the x value into the equation for the y value. So then we have an equation of y in terms of x. So we need to rearrange this equation in terms of t, substitute it into this equation, and then we'll have something in terms of y and x. So if x equals 2t minus 1, 2t will equal x plus 1, and then t will equal x plus 1 divided by 2. Okay, so now we have t in terms of x, and we can substitute that into the equation for y. So therefore y will equal 4 times x plus 1 on 2. So I'm just taking this value for t, x plus 1 divided by 2, and substituting it into this formula everywhere where I see t. So this will be 4 times x plus 1 divided by 2 minus 7 plus 3 divided by x plus 1 divided by 2. Alright, and now we need to go ahead and simplify this as best we can. So next we could say y equals, now this 2 here and this 4, they can cancel, so this becomes a 2. So this part of the equation will be 2 times x plus 1 minus 7, and then this part, this is like 3 divided by a fraction. Remember, when you're dividing by a fraction, you can flip it and multiply. So this will be like 3 times 2 on x plus 1, which just becomes 6 on x plus 1. And now we want a common denominator. Well, the only way we can do that is to multiply everything by x plus 1. So the next line will be 2 times x plus 1 multiplied by x plus 1 minus 7 times x plus 1 plus 6, and now I can write that all over x plus 1 to turn that into a single fraction. And now I can go ahead and simplify the top line as best I can. So expand these brackets out. So this will be x squared plus 2x plus 1 minus 7x minus 7 plus 6 all over x plus 1. And let's keep going with this. So expand that 2 out. So this will be 2x squared plus 4x plus 2 minus 7x, and minus 7 plus 6, that's minus 1 all over x plus 1. And let's keep going. So that 2x squared is still the same. 4x minus 7x, that's minus 3x. And 2 minus 1, that is plus 1 all over x plus 1. And I think we're about there. So let's have a look again. We needed 2x squared plus ax plus b, and we need to give values for a and b. So a in this case is minus 3. So a equals minus 3, and b equals 1. That was question 5 for 3 marks. Question 6 says a company plans to extract oil from an oil field. The daily volume of oil V measured in barrels that the company will extract from this oil field depends upon the time t years after the start of drilling. The company decides to use a model to estimate the daily volume of oil that will be extracted. The model includes the following assumptions. The initial daily volume of oil extracted from the oil field will be 16,000 barrels. The daily volume of oil that will be extracted exactly 4 years after the start of drilling will be 9,000 barrels, and the daily volume of oil extracted will decrease over time. The diagram below shows the graphs of 2 possible models. Okay, so let's just summarize what's going on. They're taking oil out of the ground, and they have 3 conditions that need to be met, and these are 2 possible values to graph the data. So on day 0, there will be 16,000 barrels, and after 4 years, there will be 9,000 barrels of oil being extracted. So this model is just a linear graph going from the y-intercept down to t, where t is years. And this graph looks more like an exponential model where where the rate of decrease is decreasing over time. Okay. Part A says use model A to estimate the daily volume of oil that will be extracted exactly 3 years after the start of drilling, and write down a limitation of using model A. Okay, so let's start with that. Let's have a look at model A and see what we can do with that. Well, the first thing we need to do to find the daily volume of oil after 3 years is to find the equation of this line. So we know the y-intercept is 16,000, and we just need the gradient. So the gradient is going to be the rise over the run. So let's write some of this down. So for part A, the y-intercept is 16,000. The gradient is the rise over the run. The rise in this case is negative 7,000 from 16,000 to 9,000. So negative 7,000 divided by 4. 0 to 4 is 4. And well, let's just put that into a calculator really quickly. Why not use a calculator if you have it? This will be 1,750. So negative 1,750. And then therefore we can say the equation of the line is y equals 1,750 negative 1,750x plus 16,000. And we want the daily volume after 3 years. Actually, let's just change that to V and T. So the volume will be minus 1,750T plus 1,600. So if T equals 3, so when T equals 3, the volume will be minus 1,750 times 3 plus 16,000. If we put that into a calculator, minus 1,750 times 3 plus 16,000, we get 10,750 after 3 years. Okay, and then part 2 asks for a limitation of this model. Well, a limitation is that it's a linear graph, so eventually it's going to go into the negative numbers, and you can't extract a negative amount of oil. So really this model is only good for a certain amount of time. Once it gets to this number of years, it won't be useful anymore. So I would just say that the daily volume will become negative, which is not possible. Or you could say something like it's limited from a certain value up to a certain number of years, and then after that number of years it will become useless because it's in the negative numbers. So something along those lines would be fine. Then part B says, using an exponential model and the information given in the question, find a possible equation of model B. Right, so now we need to think of exponential models to try to graph this curve. So the typical exponential model would be something as simple as y equals 2 to the x. So the x in this case becomes the power of some number. That's about as simple as you can get in terms of an exponential model. In this case, you can also have a coefficient of this number, so we could say v equals a, and then we have that number, so we don't know what that number is yet, but it's just a fixed number, it's not a variable. I'm calling it r because I don't know what it is yet, but it's not a variable, it's definitely a fixed number. And then we have the power, which is the variable x. So in this case, we're trying to solve for r. There are other cases where you could use e, so we could say the volume is equal to the coefficient a times e to the power t. Now remember, e is a fixed number. So if you give that fixed number, you have to introduce a variable in the power. So we have to actually say the variable is kt, and you have to find the value of k in this case. But I'm going to use this model. I don't see the value in using e for this question, and it is an exam situation, so I also care about the time limit of the exam. So I'm going to use v equals a r to the power x, and I can solve this for r. So remember, when x equals 0, we would get a. So r to the power 0 is 1, so we'd be left with a. So we know that a is the y-intercept, 16,000. So we can say the volume equals 16,000 times r to the power x. And then we can substitute this second point, this 4 and 9,000 in, to find r. So we could say that the volume is 9,000, and this equals 16,000 times r to the x years. So in this case, x was 4, and this will allow us to solve for r. So r to the power 4 will be 9,000 divided by 16,000. And then r equals the fourth root of that, so let's just do that on a calculator. So we can do the fourth root of 9,000 divided by 16,000, and we get 0.866 approximately. So we'll leave it at that, 0.866. So therefore, the equation of the model can be written as v equals 16,000 times 0.866 to the power of x. But in this case, remember, x was t, the number of years, so I'll just write t in this case. So the volume will be 16,000 times 0.866 times t. And that's our exponential model we're going to use for that. Part 2 says, using your answer to bi, estimate the daily volume of oil that will be extracted exactly 3 years after the start of drilling. So when t equals 3, we need to find the volume of oil. So when t equals 3, v is going to equal 16,000 times 0.866 to the power of 3. And we just need to put that into a calculator and come up with our answer. So this will be 16,000 times 0.866 to the power of 3, and we get 10,391.39 barrels. Oh, that's not right, barrels yet, we need to round that off. So approximately 10,000, well, let's just round this off to 400, 10,400 barrels. And so there you go, that's using this particular exponential model. If you check out the mark scheme, they give a solution using E, but I'm not going to go through that. I think it's just easier to use this method. And if we're talking about an exam situation where you have a time limit, I don't see the value in using E in that case. I would just use kind of the basic exponential model. And the answer they're looking for in the mark scheme is any number rounding off to 10,400. So clearly this is a good enough model to get the correct answer. And that was question 6 for 7 marks. Question 7 says, figure 2 shows a sketch of a triangle ABC. Given the vector AB equals 2i plus 3j plus k and BC equals I minus 9j plus 3k, show that BAC equals 105.9 to 1 decimal place. Right, so here we are given these lengths basically in terms of vectors. Remember, I, j, and k are just unit vectors. They are the unit vectors of the Cartesian coordinate system. So remember, if we're talking about the x and y grid, we also add the z axes when we're talking about three-dimensional geometry. I is the unit x vector, so this would be I of 1 unit. J is the unit vector on the y-axis, and k is the unit vector on the z-axis. These are just vectors with 1 unit in length. So if we're looking to find the length of these vectors, AB, AC, and BC, we can kind of ignore those I, J, and K to find the length, or if we're talking about vectors, we would say the magnitude. So we can find the magnitude of AB, which can be written with those 2 lines showing the size. We can do that using ideas of 3D geometry. And if you want to picture this graphically, you're kind of looking for the diagonal of a cuboid. So if you had a cuboid, I'll try to draw one really quickly. If you're looking for this, the size of this vector, you're looking for the diagonal of the cuboid from this corner up to this top corner here. And the dimensions of this cuboid are these vectors. So this is 2i, the height is 3j, and the width is 1k. So you've got the dimensions and you're just looking for the diagonal, and we have a formula for that. It's related to the Pythagorean theorem, but basically we just need to take the square root of the sum of the squares of those dimensions. So we can say this will be the square root of 2 squared plus 3 squared plus 1 squared, and that gives us the diagonal of that cuboid with those dimensions. So we can find the size of AB using this formula. So this is going to be the square root of 4 plus 9 plus 1. 4 plus 9 plus 1 is 14. So the magnitude of AB is the square root of 14. Then we can also find the magnitude of BC using the same method. So this will be the square root of 1 squared plus 9 squared plus 3 squared. I'll just ignore the negatives because when we square a number, you get rid of the negative anyway, so I don't really need to write that in there. So this will be the square root of 1 squared plus 9 squared plus 3 squared. 1 squared is 1 plus 81 plus 9, that's going to be 91, square root of 91. And we also need to find AC. AC is going to be AB plus BC. So AC, the vector AC will be AB plus BC. So I can use this vector notation to figure out what AC is. So this will be 2i plus 3j plus k plus I minus 9j plus 3k. And this makes it pretty easy to find what AC is. So 2i plus I, that's 3i. 3j minus 9j, that'll be minus 6j, and k plus 3k, that's 4k. So AC ends up being 3i minus 6j plus 4k. So therefore the magnitude of AC will be the square root of 3 squared plus 6 squared plus 4 squared. So that's the square root of 9 plus 36 plus 16, and that adds up to 61. So AC is equal to the square root of 61. Now we have all of these lengths, let's write them in. AB is the square root of 14. BC is the square root of 91. And AC is the square root of 61. And I have 3 lengths of that triangle. I need an angle in that triangle. How do we find an angle given 3 lengths? We need to use the cosine rule. So remember that the cosine rule says that the cosine of A equals B squared plus C squared minus A squared divided by 2BC. So you might have seen that written slightly differently, where it's A equals, or A squared equals, and that's just a rearrangement of that more typical cosine rule. So this will give us the angle A given these side lengths. So now we just need to substitute everything in, being careful to relate this angle BAC, this one in here, to the side BC. So this must be side A in our formula, because it's opposite this angle A. The other sides, B and C, don't really matter which ones we use. AC could be B and BA could be C in this formula, or it could be the other way around, as long as you match up that angle with the opposite side, BC, and then you'll be fine. So let's go ahead and plug everything in. So the cosine of A will equal B squared, which is 14, square root of 14 squared equals 14, plus C squared, which is 61, minus a squared, which is 91, divided by 2 lots of BC, so this will be the square root of 14 times the square root of 61. So let's just go ahead and put that straight into a calculator. So this will be 14 plus 61 minus 91, and on the bottom line I've got 2 times the square root of 14 times the square root of 61. And that gives us an answer of minus 0.27375. So we can say the cosine of A equals minus 0.274 approximately. Just round that off a little bit. And then, therefore, we can say that A is going to be the inverse cosine of this number. So minus 0.274. Now you have to be careful. If you're working with your calculator in radians, make sure to switch it to degrees before you do this. Likewise, if you're in degrees and you have a problem on radians, make sure you know how to switch your calculator between the two. So if we take the inverse cosine, you can see I did this with radians, but I've changed it to degrees, and we get 105.89 approximately, and we need to show that equals 105.9 to one decimal place, so this is 105.9. So we've shown that angle BAC equals 105.9, and that was question 7 for 5 marks. Question 8 gives us a function f of x equals the log of 2x minus 5 plus 2x squared minus 30, where x is greater than 2.5. And part A says show that f of x equals 0 has a root alpha in the interval 3.5 to 4. And this first question is for 2 marks. So what we need to do is to substitute these values, 3.5 and 4, into this equation and show that there is a solution there. Okay, so f of 3.5 is going to equal the log of 2 times 3.5 is 7. 7 minus 5 is 2, so that's the log of 2 plus 2 times 3.5 squared minus 30. And let's put that into a calculator. So we've got the log of 2 plus 2 times 3.5 squared minus 30. And we get minus 4.8 approximately, minus 4.8. Then we want to find f of 4. So this is going to be log of 2 times 4 is 8, minus 5 is 3, log of 3, plus 2 times x squared, 4 squared is 16, 2, so that's 32. 2 times 16 is 32, and then minus 30. Put that into a calculator. So the log of 3 plus 2, that gives us 3.099 approximately. So 3.099. You can see that f of 3.5 is negative and f of 4 is positive. So as we have that change of signs, there must be a solution there. So because we have a change of signs in solutions, there must be a root. There must be a root between 3.5 and 4. Okay, so that's part A. Part B goes on, it says a student takes 4 as the first approximation to alpha. Given that f of 4 equals 3.099 and f dash 4 equals 16.67 to 4 significant figures, part B says apply the Newton-Raphson procedure once to obtain a second approximation for alpha, giving your answer to 3 significant figures. So let's firstly write down the Newton-Raphson method, and then we'll go ahead and start to solve this question. So the Newton-Raphson method is basically a method of iteration, and it says that x1, the next value we're looking for, or the next iteration, is x0 minus f of x divided by f dash of x. And there's actually a nice proof of why this works. Let me know if you want me to do a video on that proof. because it is fairly intuitive and it helped me understand where this comes from. But anyway, I'm sure if you're an A-level student, you've been taught this, or I hope you've been taught this. And because we have x0 and we have f of x and we have f dash of x, we can just plug those values into this equation to find x1. So x1 will be x0. In this case, x0 was 4. F of x was 3.099. And f dash of x was 16.67. And then we just need to put that into a calculator to find the solution. So 4 minus 3.099 divided by 16.67 will give us a value of 3.814 approximately. So 3.814, and that's our second approximation for alpha. Then part C says, show that alpha is the only root of f of x equals 0. Okay, so when f of x equals 0, all of this is going to equal 0. So let's write that down. So C, when f of x equals 0, the log of 2x minus 5 plus 2x squared minus 30 equals 0. Now there are a couple ways to do this. You could try to do it algebraically, although I'm not 100% sure it's possible, but there is also a graphical method of doing this. So it involves rearranging this formula. So if this is equal to 0, therefore we can say that the log of 2x minus 5 equals 30 minus 2x squared. And this is just a log of some variable. So we know the graph of a log looks kind of like that. It goes up and then it flattens out. And this is just a quadratic, and we know what a quadratic looks like. We also know it's a negative quadratic because we have this negative 2 before the x squared. So remember, a negative quadratic is upside down like this. So we can use our knowledge of those two things to say there'll be only one intersection point. So let's draw a quick graph. Also remember that a log has to be positive. There's no negative values in a log function, so it'll look something like this. It always starts down here, crosses the x axis somewhere and keeps going up and then flattens out a little bit. So we can say this is ln of 2x minus 5. And then the quadratic must have its axis of symmetry as the y-axis because we haven't shifted this left or right in any way. So its axis of symmetry will be the y-axis, and it will be here somewhere. So that could be the graph of minus 2x squared plus 30. And we can use those two facts, that the y-axis is the axis of symmetry of this quadratic and that the log function is always positive. We can say there must only be one intersection point. So we can say that graphs only have one point of intersection, therefore only one root of f of x equals 0. And so that question was 2 marks. So overall question 8 was for 6 marks. Question 9 part A says prove that tan of theta plus the cotangent of theta is equivalent to 2 cosecant 2 theta, where theta does not equal n pi on 2 and n is an integer. So remember that z is just integers. Right, so here we need to use the trigonometric identities. Hopefully you have your formula sheet of identities with you when you're doing the exam, so you can have a look straight away at those identities and you don't have to memorize them. So let's start off with the left-hand side, which is the tan theta plus cotangent theta. And we need to transform this into something that equals 2 cosecant 2 theta. I'm never really sure where to start with questions involving trigonometric identities. I usually just have kind of a play around, change some things, see if I can get to the solution. And I'm never really 100% sure that what I'm doing is the correct way to get there. But in this case, I was fairly confident that I needed to start with changing the tangent into sine theta over cosine theta. Remember, the tangent is just the ratio of the sine and the cosine, and the cotangent is the opposite of that. So that's the cosine over the sine. So I was fairly confident that's where I needed to start. I wasn't sure how else I could start this problem. And then I can combine these two fractions. So find the common denominator, which is sine cosine, and we end up with multiply this by sine theta, and we get sine squared theta plus cosine squared theta all over sine theta cosine theta. So I've just combined those two fractions with a common denominator. And here you can see we've got sine squared theta plus cosine squared theta, and that's that famous identity, and that equals 1. So I can say on my next line this is equal to 1 over sine theta cosine theta. And now I feel like I've made some progress, and I can use the double angle formula to change this a bit more. So remember, the double angle formula says that sine 2 theta equals 2 sine theta cosine theta. And so we can do something a little bit fancy here. We can multiply this by 2 divided by 2. This is the same as multiplying by 1, so we haven't changed anything. So this becomes 2 over 2 sine theta cosine theta. And now you can see that we can change this bottom line into sine 2 theta. So this is going to equal 2 on sine 2 theta. There's another way of stating this angle formula. You can say that the half sine 2 theta equals sine theta cosine theta. That's the same thing. So you didn't have to do this 2 divided by 2. You could just say this equals a half sine 2 theta. That's something else you need to memorize, so you can still do it without having to worry about that extra formula. So now we've got 2 over sine 2 theta, and let's write this a little bit differently. This could be written as 2 times 1 on sine 2 theta. And remember that 1 on sine theta is the definition of the cosecant. So 1 on sine 2 theta, that will be 2 cosecant 2 theta, which is what we're looking for. So that equals the right hand side, and we are done. Part B says, hence explain why the equation tan theta plus cotangent theta equals 1 does not have any real solutions. Right, so we're going to have to go backwards a little bit here. So remember that the tangent of theta plus the cotangent of theta from the first question, this equals 2 cosecant 2 theta. And so using this equation, we can say if tan theta plus cotangent theta equals 1, then 2 cosecant 2 theta equals 1. And let's go backwards a step. So 2 cosecant 2 theta was the same as 2 over sine 2 theta. So therefore 2 over sine 2 theta equals 1. If this is the case, 2 divided by something equals 1, that means sine 2 theta must equal 2. But that's not possible, so therefore we can say there are no solutions, as the sign of anything must be between -1 and 1. Unless we change the amplitude, if it has a coefficient, then that would change the amplitude. We don't have any coefficient, it's just the sine of an angle, and that must be between -1 and 1. So there are no solutions there. When we're talking about integers, in this case, which is specified, so n is belonging to the integers, so this is not possible. That was question 9 for 5 marks. Question 10 says, given that theta is measured in radians, prove from first principles that the derivative of sine theta is cosine theta. You may assume the formula for sine of a plus or minus b, and that as h approaches 0, sine of h on h approaches 1, and cosine of h minus 1 on h approaches 0. Okay, so when they're talking about from first principles, they're talking about finding the slope of the curve given 2 points, and finding the limit as h approaches 0. So let's go ahead and make a start on this one. So the first thing we can say is y equals sine of theta, and we're looking for the derivative of y in terms of theta, and this is going to be equal to the limit as h approaches 0 of something. Now let me just break down what we're looking for in using a graph here. So when we're talking about from first principles, it does help to think of this graphically. So I'll try to draw a rough sine curve. It won't be very good, but something like that. And we need to think of 2 points on this curve. So let's say we have a point here and a point here, and we want to find the gradient between those 2 points. So how would we do that? Well, first we'd find the x value of this point. So let's just call that theta. And then we want the x value of this point here. So we'd go along a bit and we get to this point, and let's just say that that is theta plus whatever this is. So if we call this length h, this point will be theta plus h. And so this y value here will be sine of theta, remember, because y equals sine theta. And this y value up here will be the sine of theta plus h. Okay, so to find the gradient, remember that the gradient is the rise over the run. So how do we find the rise? We take the second y value and subtract the first y value, and the run is the second x value, subtract the first x value. So the derivative is this slope as h gets smaller and smaller. So that's what we mean by the limit as h approaches 0. So this interval in here is getting smaller and smaller. So the slope, as I said, would be the rise, so sine of theta plus h subtract sine of theta, y2 take y1, divided by x2, which was theta plus h, subtract x1, which was theta. Okay, so let's keep going with this. Let's simplify this a little bit. So it's the limit as h approaches 0 of sine of theta plus h, subtract sine of theta, divided by, now that theta minus theta, they cancel out, so we're just left with h on the bottom. And now we can use the sum formula for sine. Remember that sine of a plus b equals sine of a cosine of b plus cosine of a sine of b. We can use that formula to say that this will be the limit as h approaches 0 of the sine of theta cosine of h plus cosine of theta sine of h minus sine theta all over h. Then we can rearrange this a little bit. So again, always writing that limit. Let's combine the sine thetas together and then we can factorize them. So this will be the sine of theta cosine h subtract sine of theta plus cosine of theta sine of h. And I might separate these fractions as well. So I'll separate this part and factorize this. So this is now going to be sine of theta cosine of h minus 1. I've just factorized out the sine theta all over h. And this part, this cosine of h minus 1, that approaches 0, because remember that cosine of 0 equals 1. And so 1 minus 1, that will turn into 0. So this, effectively, this part of the fraction cancels itself out because this will turn into a 0 and everything else multiplied by 0 will be 0. And over here, we could rewrite this as cosine of theta times sine of h on h. And sine of h on h approaches 1 as h approaches 0. Now you might think that's a bit counterintuitive because sine of 0 equals 0. But if you think of this as a ratio, it does make sense. I won't go into any more detail now because I think if I try to explain that, I'll just confuse you because I'll go over it too quickly. But if you want me to do a video on why sine of h on h approaches 1 as h approaches 0, I can. It's not too complicated, but it's just a bit too lengthy to go over at the moment. So this turns into 1. So therefore we can say the derivative will be 0 plus cosine theta times 1, which is just cosine theta. And so we have proven that the derivative of sine theta is cosine theta from first principles. And that was for 5 marks. Question 11 says, an archer shoots an arrow. The height h meters of the arrow above the ground is modeled by the formula h equals 1.8 plus 0.4 d minus 0.002 d squared, where d is greater than or equal to 0, and where d is the horizontal distance of the arrow from the archer measured in meters. Given that the arrow travels in a vertical plane until it hits the ground, part A says find the horizontal distance traveled by the arrow as given by this model. Okay, so this is clearly a quadratic formula modeling the vertical height of the arrow with respect to the horizontal distance. And that makes sense because if you think of firing an arrow into the sky, it would go up into the air and then come back down to the ground, taking this path, which looks like the graph of a quadratic. So where the arrow is fired from is where the archer is standing, and where it hits the ground will be some distance d away from the starting point. So what would be the value of h when the arrow is fired and when it hits the ground? Well, when it's fired, it's the distance from the ground of the archer, so it'd be whatever height the archer is off the ground, but when it hits the ground, the vertical distance would be 0, so h is going to equal 0 when the arrow hits the ground. So to find the horizontal distance, d, we can make this formula equal 0. So we can start with that. So for part A, we're going to say that the arrow hits the ground. The arrow hits the ground when h equals 0. So therefore, this whole formula will equal 0. 1.8 plus 0.4d. I might just rewrite that so the d squared is at the front. So this will be minus 0.002 d squared plus 0.4d plus 1.8 equals 0. And that's in the form of a traditional quadratic where we have the d squared and then the d and then the number at the end. And to solve this, you could try to factorize it, but I don't think you can factorize it, so we have to use the quadratic formula to solve for d. So the quadratic formula says that d equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So a is the coefficient of d squared, b is the coefficient of d, and c is the number on the end there. So if we put all of those numbers into this formula, we'll be able to solve for d. So we can get our calculator out and plug all of these numbers in. So minus b, that's minus 0.4, plus, I'll do the plus first, and then I'll do the negative, b squared, so 0.4 squared, minus 4ac, so 4 times minus 0.002 times 1.8, and then on the bottom line we've got 2 times a, so 2 times 0.002, and just make sure you've put everything in correctly. Oops, this is a negative here, so I get minus 4.4, so that's one possible answer. Or we need to now do the negative, so we can just go back and edit this. So replace this plus with a negative, and we get 204.4 approximately. So clearly the horizontal distance can't be a negative number, so therefore the horizontal distance must be the positive number here, 204.4. So we can say therefore the horizontal distance equals approximately 204.4 meters. Okay, that's part A. Part B says, with reference to the model, interpret the significance of the constant 1.8 in the formula. So remember, this is 1.8 plus all of this. So when d is 0, we will have that 1.8 that's kind of the starting vertical height. So that must be the height of the archer, so the height that the arrow is fired from when the horizontal distance is 0. So we can say that for B, that 1.8 meters is the height of the archer. Let me just check. That's 1 mark, so yeah, just need a quick explanation to show that you can interpret what that 1.8 means. Part C says write 1.8 plus 0.4d minus 0.002d squared in the form a minus b bracket d minus c squared, where a, b, and c are constants to be found. Alright, so we need to rearrange this formula slightly in the form of a minus b d minus c all squared. So let's start off with the formula we're given. So we're given 1.8 plus 0.4d minus 0.002d squared. We need to get it in this form somehow. So clearly we're going to have to factorize something. So let's say this equals 1.8, and I'm just going to write this minus 0.002 first, just because I find it easier personally. This is an extra step that clearly you don't have to do, but I find it easier. So just rearrange that slightly, and then on the next line I'm going to factorize out a 0.002 from both terms. So this is going to be 1.8, and a 0.002, if I take that out of this, I'm just left with d squared. And if I take 0.002 out of 0.4, you could think if you multiplied both of these by 1,000, this would be 400, and this would be 2. So if you take 2 out of 400, what are you left with? You're left with 200. And it's still the same if you factorize 0.002, because you multiply them both by the same number. If you don't believe me, you could just use a calculator. So 0.4 divided by 0.002, and you get 200. So I factorize 0.002 out of both terms, and I'm left with d squared plus 200d, and that becomes a negative because I've factorized out negative 0.002. And why have I done that? Because what I actually want to do in the end is to do the process of completing the square, and that becomes easier if I have this d squared in this d with some slightly easier numbers than 0.4 or 0.002. So I want to get to a point where I can use the completing the square method. So the next line is 1.8 minus 0.002, and now for d squared minus 200d, I can see that this can be written as d minus 100 all squared. So remember, when you're doing completing the square, you just half the coefficient of d and square the whole thing in brackets, and then you have to take away the square of the last number. So 100 squared, that's 10,000, so I need to subtract 10,000 in order to make these two equations equal. And then if I expand these brackets out again, so I'll have 1.8, and I'll expand this 0.002 to these brackets and this 10,000. So I'll have 0.002 d minus 100 squared, and then 10,000 times 0.002. So we'll just be left with 20, and that becomes a positive because we have a negative and a negative. So I've expanded those brackets out, I've got rid of those brackets, so now I can add this 20 to this 1.8, so 1.8 plus 20, that's 21.8, minus 0.002 d minus 100 all squared, and this looks like what we needed, so this is a minus b bracket d minus c all squared, where a equals 21.8, b equals 0.002, and c equals 100. But yeah, the key there was to notice you had to use completing the square. Part D says it is decided that the model should be adapted for a different arch. The adapted formula for this archer is h equals 2.1 plus 0.4d minus 0.002d squared. Hence, or otherwise find for the adapted model d part 1, the maximum height of the arrow above the ground, and part 2, the horizontal distance from the archer of the arrow when it is at maximum height. So the model's changed just slightly. So we've changed this 1.8 to 2.1 to recognize that the second archer is just a bit taller than the first archer, but these numbers are still the same, and we need to find the maximum height of the arrow above the ground and the horizontal distance when the arrow reaches that maximum height. So if you think of a quadratic graph, that maximum height will be the turning point of that quadratic graph. So we need to figure out how we can find that turning point of the flight of the arrow, and then figure out how we can find that horizontal distance. Now, if you think of the equation for a quadratic graph in this form, when it's written in this form, that actually gives you the turning point of a quadratic graph, and you can read that straight off the equation when it's written in this form: a minus b bracket d minus c all squared. So when you have it in this form, c is the x value and a is the y value of the turning point. So we already have the answer basically in part C that we've already done. So because we've written the equation in this form, we can read off the turning point. That will give us the maximum height and the horizontal distance to that maximum height, just from reading the numbers out of this formula. So let's have a look carefully at this one. So when the arch was 1.8 meters tall, the turning point was 121.8, but for the second archer, the original height is 2.1. So is there an easier way to just adapt this equation for that new height? Well, all that would change in our working out is we'd add 2.1 to 20 here in this last step, rather than 1.8. So this new equation would look, so let's just write the new equation out. So this was 2.1 plus 0.4d minus 0.002d squared, and this would be written as, if we were to use these steps to rearrange it, this could be written as 22.1, right? 2.1 plus 20 is 22.1, and then we'd have the same thing on the end, so we'd have minus 0.002 d minus 100 squared. That's all that changes, and if you need to do some reasoning, you can just say by analogy. By analogy means that you've already answered these steps in the previous question, or you could say from part C. So that explains how you get to that step from this first equation. And now we can say that the turning point of this graph is going to be 122.1. So we can say, therefore, the maximum height is the y value of the turning point. So that's 22.1 meters. And the horizontal distance to the maximum height is going to be 100 meters. So that's all that you need for part D, part 1. Oh, and that was part 2 as well. So that was only 2 marks, because as long as you recognize, you can read that those are coordinates of the turning point from the equation, then there's not much working out there. So this was part 2. And for a total of 9 marks for question 11. Question 12 says, in a controlled experiment, the number of microbes N present in a culture T days after the start of the experiment were counted. N and T are expected to satisfy a relationship of the form N equals A T to the power B, where A and B are constants. Part A says, show that this relationship can be expressed in the form log N equals M log T plus C, giving M and C in terms of the constants A and or B. So what we need to do for part A is to take this equation, N equals A T to the power B, and somehow express it in this form, log N equals M log T plus C. Okay, so for part A, we can start off just by writing that equation down again. And because we have logs in this equation, let's take the log of both sides and see what happens. So log base 10 of n equals log base 10 of a t to the power b. And now what we have on the right hand side is a log of two numbers multiplied together. And remember, when we have a log of something times something else, we can write this as log of a plus log of b. So we'll expand that right hand side out, so this will be log 10 of n equals log base 10 of a plus log base 10 of t to the power b. And also we know that when we have a log of a number and it's raised to some power, that power can then become the coefficient. So that rule is basically log of a to the power b equals b log a. They're the same thing. So we can rewrite this right hand side again as log base 10 of n equals log 10 of a plus b log 10 of t. And actually what I should have done is write that at the front there. So this should be log base 10 of n equals b log 10t plus log of a. And remember, they wanted it in the form of log of n equals m log t plus c. Well, we have this m, essentially b equals the m, or the gradient, log t plus log of a, where a is a constant as well. So in this case, we can say that m equals b and c equals log base 10 of a. And you notice that this is kind of in the form of a classic kind of linear equation where y equals mx plus c. So m is kind of the gradient and c is the y-intercept. So this is a way of kind of finding an equation for this line where we can have the gradient and the y-intercept. Okay, so that's part A. We've now written it in that form and we've found m and c. So the question goes on. Figure 3 shows the line of best fit for values of log base 10 of n plotted against values of log of t. So here we have log of n going from 0 to 5, and here we have log of t going from 0 to 1.4. Remember, this was the microbes, n was the number of microbes, and t was the number of days. So now we have the log of those two things. Part B says use the information provided to estimate the number of microbes present in the culture 3 days after the start of the experiment. So this will be, remember, t was the number of days. So we could let t equal 3, then take the log of 3 to find the value on the x-axis, and then that would give us the corresponding log of the number of microbes, and then we'd have to work with that number to find n. So let's start with that. So for part B, we'll say that t equals 3 days. And then to use this graph, we need to take the log of 3. So you can get your calculator out and take the log of 3, and that's 0.477 approximately. So we should write that down actually. So the log base 10 of 3 equals 0.477 approximately. And now we can use this graph to find the corresponding number of microbes. So if we look at this scale, it's going up in 200ths, I believe. So 0.42, 0.44, 46, 48, 0.5. So 0.48 about will be here. So if we go up to the graph, so draw a straight line up to the graph at 0.48, and then we go across to the y-axis, and this side of the graph is going up in Well, every 2 lines is a tenth. So this is 2.6, 2.7, 2.8, and 2.9. So this value here will be 2.9, and that is log of n. So log of n equals 2.9. So therefore log base 10 of n equals 2.9, and that's after 3 days. And now how do we find what n is when we have the log of n equal to 2.9? Well, we have to raise that to the power of 10 because that's what the log is. That's the value when we have 10 to the power of 2.9. So we can just do that. 10 to the power of 2.9 equals, and do that on our calculator, 10 to 2.9, and we get 794.33, approximately 794.33 microbes, and that's fine for a final answer. The mark scheme says any answer that rounds to 800. There is another way of doing this problem. You could find the gradient of the line. So using this graph, you can find the gradient and the intercept, and then using this equation here, this log of n equals b log t plus log a, you can find the value when t equals 3 just as you would with a straight line graph. So that's another approach. I didn't like that approach as much because there's more areas to make mistakes. So firstly you have to find the gradient, and there's a slight error finding the gradient from the graph, and then you also have to find the y-intercept, and there's a slight error there. So if you're just making one measurement from the graph, I feel that you're less likely to make a mistake, or that it's more accurate. But there are 2 ways to do it. I'm not sure which one's the best way, but in terms of the quickest or the simplest way, I feel this is the simplest way. Okay, so on to part C. Part C says explain why the information provided could not reliably be used to estimate the day when the number of microbes in the culture first exceeds 1 million. So remember that the log of 1 million, that will be 6. So if the number of microbes is 1 million, log of n, or remember that n is the number of microbes, so log of 1 million would be 6. That's outside of the range of this graph. So we'd have to keep going. 6 would be up here, and we clearly haven't graphed that far, and so that's outside of the range of data. So we can say for C, n equal to 1 million, n equal to 1 million is outside the range of data, and we could just say that log of 1 million equals 6, just to show that we're understanding why that's outside the range of data. And part D says, with reference to the model, interpret the value of the constant A. Okay, so let's go to the second page. So part D, remember the model said n equals at to the power b. So when t equals 1, t to the power b will equal 1. Doesn't matter what b is, 1 to the power of anything is just 1. And remember that t is the number of days. So when t equals 1, or 1 day after the experiment starts, t to the power b will equal 1. That means that when t to the power b equals 1, n equals a. In other words, the number of microbes equals a. So this is saying that 1 day after the experiment, a is the number of microbes in the culture. So we can state that in a sentence. So a is the number of microbes when t equals 1, i.e. 1 day after the experiment has started. You could also make the argument that t to the power b equals 1 when b equals 0. So when b equals 0, t to the power b equals 1. But this is kind of meaningless. We don't really know what this means. This is kind of like the growth rate. So when the growth is at 0 in the culture, that would be the number of microbes. There's not really any meaningful statement you can get out of this reasoning. So you can kind of ignore when b equals 0 and just stick with when t equals 1, t to the b equals 1. So that was question 12 for a total of 9 marks. Let's just go back to the marks again. Part A was 2 marks, Part B was 4 marks, C was 2, and D was 1 mark. Question 13 says the curve C has parametric equations x equals 2 cosine t and y equals the square root of 3 cosine 2t, where t is between 0 and pi. And part A says find the expression for the derivative dy and dx in terms of t. So the first thing we can do here is find the derivative dx on dt and then dy on dt, so the derivative of these two expressions separately, and then we'll be able to combine them to find dy and dx in terms of t. So let's start with that. We'll find the derivative of x in terms of t. So x equals 2 cosine t, and now we want dx on dt. Well, the derivative of cosine is minus sine, so this is going to be minus sine t for dx on dt, and then y equals the square root of 3 cosine 2t, and the derivative dy on dt. So again, the derivative of cosine is minus sine, and we also have to apply the chain rule here because we have this 2t inside this cosine. So we need to take the derivative of the cosine, which will be minus sine, and then the derivative of 2t, which is 2, so all of that together will be minus 2 root 3 sine 2t. So again, I've just applied the chain rule there to take the derivative of the function inside the cosine as well. Alright, so now we have dx on dt and dy on dt, and if we combine these, dy on dt divided by dx on dt, if you flip that fraction over and multiply, you'll end up with dy on dx. So if we divide these two things, we'll end up with dy on dx. So we can take dy on dt, which is minus 2 root 3 sine 2t, and divide that by dx on dt, which was minus 2 sine t, and the minus 2's cancel out there, so we're left with root 3 sine 2t on sine t. And remember the double angle formula for sine 2t. Sine 2t will be 2 sine t cosine t divided by the sine of t. And now we have a sine of t on the top line and a sine of t on the bottom line, and they can cancel out. So we're left with 2 root 3 cosine t for the derivative dy on dx, and that's in terms of t. So 2 root 3 cosine t is your final answer there. The question goes on, the point P lies on C where t equals 2 pi on 3. The line L is the normal to C at P, and part B says show that the equation for L is 2x minus 2 root 3y minus 1 equals 0. Okay, so it might just help to try to quickly picture what's going on here. Now I don't know what this curve will look like, but let's attempt a quick sketch of it anyway. So let's just say it goes like this, and we have a point at t equals 2 pi on 3. So say that's there, and this is t, and this is the curve C, and this is the point P. So the point P lies on C where t equals 2 pi on 3, and the line L is normal to C at P. So the normal line is perpendicular to the tangent. So if we draw a tangent at P, the normal line would be perpendicular to that tangent. So this is the line L, the normal line to C at P. And we're looking for the equation of L. Now a couple of things are going to help us find the equation for L. Firstly, the gradient of this tangent, which we already have. We have this derivative in terms of t, so that's going to help us find the gradient of the tangent, which will then help us find the gradient of L. And we also have the x coordinate, in other words t, 2 pi on 3. So we have a point on that line and we can find the gradient. So those two things will help us find the equation of L. Okay, so let's make a start down here. So the first thing we want to do is to find the gradient of C at point P. So that's when t equals 2 pi on 3. So dy on dx, the gradient of C, will equal 2 root 3 cosine of 2 pi on 3. So I've just taken this derivative, dy and dx, should write that there, which is 2 root 3 cosine t, and substituted that value of t into that equation. And now I need to know the absolute value of cosine of 2 pi on 3. It's almost the same as the cosine of pi on 3, which hopefully you know, but it's just in a different quadrant. So remember, you can split the unit circle up into 4 quadrants. This 2 pi on 3 is in the second quadrant, so this will be a negative. So it's the same as pi on 3, but it's a negative. So it's minus a half. Cosine of 2 pi on 3 is minus a half. So this will be 2 root 3 times minus a half. And there we have that 2 and that half cancelling out. So we just end up with minus root 3 for the gradient at P. So now we have the gradient. We have a point on the line. So we can use those parametric equations to find the x and y coordinates. So x, remember that x equals 2 cosine t. So therefore x equals 2 times a minus a half. We've already found the cosine of 2 pi on 3. So I've just substituted that in for the t there. So x is going to equal minus 1 at P. And also y equals root 3 cosine 2 lots of 2 pi on 3. This is root 3 cosine 4 pi on 3. And this is also equal to a minus a half because this is in the third quadrant. Again, it's the same as the cosine of pi on 3, but it's in the third quadrant of the unit circle. So this is going to be root 3 times minus a half again. And then we get minus root 3 on 2 for y. So we have the x coordinate and the y coordinate at point P. We also have the gradient, so that should be enough information to find the equation for L. So we can say the equation for L will look something like this, while the gradient, remember this is normal to the tangent, so if the gradient of the tangent is minus 3, we need the negative reciprocal for the perpendicular line. So the negative reciprocal of minus root 3 is 1 on root 3, which can also be written as root 3 on 3. That's the same thing. And I'm not sure which one I'll use yet, but we'll see which one makes it easier to work out. So therefore y equals root 3 on 3x plus c. And then we can substitute in x and y to find c. So the y value was minus root 3 on 2 equals root 3 on 3, and the x value was minus 1 plus c. And then we just need to do some algebra to work c out. So c is going to equal, now we have a negative root 3 on 2 on the left and a negative root 3 on 3. So on the right, if we bring everything over onto the same side, we'll get minus root 3 on 2 plus root 3 on 3. So that negative becomes a plus when we bring it over to the other side of the equal sign. And so let me bring this up here. So now we have root 3 minus root 3 on 2 plus root 3 on 3. Well, let's just make the denominators the same. So we multiply this one by 3 and this one by 2. So we get minus 3 root 3 plus 2 root 3 all over 6. And then minus 3 plus 2, that's minus 1. So minus root 3 on 6 is our final answer for C. So now we have the gradient and the y-intercept, so we can say the equation of L looks something like this: y equals root 3 on 3x minus root 3 on 6. But remember that we had to show that it equaled something else. We had to show it equaled 2x minus 2 root 3y minus 1 equals 0. So we actually have to get it in this form. So we still need to do a bit of rearranging here. So the first thing I'm going to do is to actually reverse these square root 3's, so they're on the bottom of these equations. So it's kind of like the reverse of rationalizing. And I'm not sure if this is the quickest or the simplest way, but it's just one way I found. So if you found a quick way to do this, then leave a comment letting me know. So this is actually equal to 1 on root 3x minus 3 on 6 root 3. So you can see I've just reversed the rationalization of those fractions. This is still the same. 3 on 6 root 3 is the same as root 3 on 6. It's just written differently. And so then I can say y equals 1 on root 3x minus 1 on 2 root 3. And then if I multiply everything by root 3, I get root 3y equals x minus a half. And then if I multiply everything by 2, I get 2 root 3y equals 2x minus 1. And then if I just rearrange this so that everything is on the left hand side, I get 2x minus 1 minus 2 root 3y equals 0. And that is the equation that we're looking for. So probably not the simplest way to do that question. Just some of the algebra could have been a bit neater, I think, but hopefully you get the idea that firstly you find the gradient at P, then you can find the x and y coordinates, and then basically using that y equals mx plus c, that basic formula of a straight line, you substitute everything into that equation and then rearrange it to get the equation they were looking for. And possibly you can do it in a slightly neater way than I did. But that's part B for question 13. And the question goes on: the line L intersects the curve C again at the point Q. Find the exact coordinates of Q. You must show clearly how you obtained your answers. Okay, so something slightly off with my diagram. This line is intersecting the curve 3 times, but it should just be twice. But we need to find a point where the line intersects the curve again. So what we can say is that the line will meet the curve at some value of t where the x and y coordinates are equal. So the x and y coordinates of L and C will be equal. So we have the x and y coordinates of C. So let's start this problem down here. So we can start by stating our reasoning. So the line meets a curve at t where x and y coordinates are equal. So for the curve C, x equals 2 cosine t and y equals the square root of 3 cosine 2t. And for the line L, 2x minus 2 root 3y minus 1 equals 0. So what I'm saying is that at the point where the line and the curve meet, this x coordinate and this y coordinate will satisfy this equation. Remember, this is the equation for the straight line L, and these 2 points, this x and this y, will be 2 points on this line when the curve and the line meet. So what we can do is to substitute these values for x and y into this equation, and then the solutions will be where the line and the curve meet. So therefore I can say when line and curve meet, 2 times 2 cosine t minus 2 root 3 multiplied by root 3 cosine 2t minus 1 will equal 0. And then we can just solve this equation for t, and that will give us the point at t where the line and the curve meet. Okay, so now we need to go ahead and start solving this. So firstly, expand the brackets out. So this is going to be 4 cosine t minus root 3 times root 3 is just 3, so 2 times 3 cosine 2t minus 1 equals 0. So this is going to be 4 cosine t minus 6 cosine 2t minus 1 equals 0. And now you have to think, how can you start to solve this equation? Well, it's kind of difficult in this form. I can't see how we could go ahead and solve this. Firstly, we have this 2t here and only a t here, so that makes it hard to do anything with these cosines because they have kind of a different function inside of them. So what I want to do is to get rid of this cosine of 2t using the double angle formulas. So the cosine of 2t, that equals 2 cosine squared t minus 1. So firstly I'll substitute that in for cosine of 2t. So 4 cosine t minus 6 multiplied by 2 cosine squared t minus 1 equals 0. Now that minus 1 is not this minus 1, that comes from this formula. So we still have this minus 1 on the end. And so then we can rearrange this a bit, so expand those brackets out again. So this will be 4 cosine t minus 12 cosine squared t minus plus 6, because that's a minus 6. So minus 6 times minus 1 is plus 6, minus 1 equals 0. And then simplify a little bit more, so therefore, and then I'll bring the cosine squared up the front of the equation. Then it starts to take the form of a traditional quadratic equation. So this will be minus 12 cosine squared t plus 4 cosine t and plus 6 minus 1, that's plus 5, equals 0. And then because I don't like negatives in the front of the squared term, I will divide everything by a negative 1. So therefore 12 cosine squared t minus 4 cosine t minus 5 equals 0. That's just a personal preference. I find factorizing quadratics easier when there is a positive number as the coefficient of the squared term. But now we have kind of a quadratic equation. We have a squared term, we have the term by itself, and then we have a number on the end, just as you could think of a normal quadratic equation. So this looks like 12x squared minus 4x minus 5 equals 0. And this is something that hopefully we can factorize and then solve. So can we factorize this? Is there some factors of 12 and 5 that sum to 4? So if we take the factors of 5, well, the only factors of 5 are 5 and 1. And some factors of 12, let's try, say, 12 and 1. So 1 times 12 is 12, 5 times 1 is 5. 5 and 12 don't make 4, so they're not going to work. Let's try some other factors of 12, such as 6 and 2. So 1 times 6 is 6, 5 times 2 is 10. 10 and 6 make 4, so this could work. And we need a negative 4, so that needs to be a negative 10. So negative 5 times 2, that's negative 10. And 1 times 6, that's 6. So minus 10 plus 6, that will make negative 4. So we can use these factors, 1, minus 5, 6, and 2, to factorize this equation. So this is going to look something like this. So we draw in our two brackets, and these are the coefficients of the cosine. So if we have 6 cosine t here, and 2 cosine t here, the 1 needs to match up with the 6, so that goes on the end here, that's a positive 1, and the minus 5 goes in here next to the 2. Okay, so we've factorized that equation, and now we can go ahead and solve for t. So either 6 cosine t minus 5 equals 0, or 2 cosine t plus 1 equals 0. Remember, either this bracket equals 0 or this bracket equals 0 to make the product equal 0. So that's how we get these two solutions. And then therefore rearranging these, cosine of t equals 5 on 6, or cosine of t equals negative a half. Remember, the cosine of 2 pi and 3 was negative a half, and we already have that solution. So remember, at the start of this problem, they told us a point P light on C where T equals 2 pi on 3. So we already have that solution where cosine of T equals -½ so we don't have to worry about that one. We've already accounted for that one. So we want to worry about this solution where the cosine of T equals 5 on 6. So we can say when cosine of T equals 5 on 6, and remember that x equals 2 lots of the cosine T. So therefore x will equal 2 times cosine of T, which is 5 on 6. So this will be 5 on 6, which is 10 on 6, or 5 on 3. So we have the x value for where the line cuts the curve, and now we need the y value. So I'll just go to the next page. So remember y equals the square root of 3 cosine 2t. And because we have only the cosine of t, we can't just double that number to make it equal to cosine of 2t. We need to use this double angle formula again. So this equals the square root of 3 2 cosine squared t minus 1. And expand that out, so we'll get 2 root 3 cosine squared t minus root 3. And then we can substitute this value for the cosine of t and square it to find y. So we get y equal to 2 root 3 5 on 6 squared minus root 3. So then 5 on 6 squared, that's 25 on 36. So 2 root 3 times 25 on 36 minus root 3. And then we just need to simplify this to get to a final answer. So that 2 will cancel with this 36. So we'll get 25 root 3 on 18 minus root 3. And then we need to make the denominators equal. So multiply this root 3 by 18 on 18. So we get 25 root 3 minus 18 root 3 on 18. And then 25 minus 18, that's 7. So on the top line we get 7 root 3 on 18 to find the y value. So that was a fair bit of work there just to get the y value, but we got there in the end. So let's go back to the question just to make sure we've answered everything. Remember, the question was saying the line L intersects the curve C again at the point Q. Find the exact coordinates of Q. So we needed the x and y coordinates. So we've shown clearly how we get to the answer, so we should just state at the very end the coordinates of Q equals, and the x coordinate was 5 on 3 and the y coordinate was 7 root 3 on 18. Okay, so that was for a total of 13 marks. Let's just go back to the marks again. So part A was 2 marks, part B was 5 marks, and part C was 6 marks. Question 14 gives us a graph, and it says figure 4 shows a sketch of part of the curve C with equation y equals x squared log of x over 3 minus 2x plus 5 where x is greater than 0. And it says the finite region S, shown shaded in figure 4, is bounded by the curve C, the line with equation equals 1, the x-axis, and the line with equation x equals 3. The table below shows corresponding values of x and y with the values of y given to 4 decimal places as appropriate. And here they give us the table. And part A says use the trapezium rule with all the values of y in the table to obtain an estimate for the area of S, giving your answer to 3 decimal places. Okay, so we need to estimate the area of this shaded region using the trapezium rule. And they've given us the values of y on this curve for every value of x going up in increments of a half. So for the value of x equal to 1, which is here, the y value is 3. For x equal to 1.5, the y value is 2.3041, etc., all the way up to x equals 3, and we're given the y value here. Okay, so let's start off with part A using the trapezium rule, and let's write that down here. So for part A, we need the trapezium rule, and the trapezium rule says that the area is equal to half the height, where the height is the intervals going up on the x-axis, In other words, you can think of that as the height of the trapeziums that you're drawing in this area. So half height multiplied by y0, in other words the first y value of our region, plus 2 times the rest of the y values added together, so y1, y2, going up to the second last y value, which we write as y sub n minus 1, and they're all added together. And then we add the last y value on the end, so y to the n, whatever that last value is. In this case, y goes up to where x equals 3, so this would be the last y value in our case, and that's it. So while that might look a bit fancy, and I'm sure you've seen the trapezium rule before if you're studying A levels, but all it is a rearrangement of adding the areas of each trapezium together. So it's just trying to make the work less difficult when you're estimating this area by breaking it up in trapeziums. So remember the formula for the area of a trapezium is the top plus the bottom multiplied by the height divided by 2. All that the trapezium rule is a rearrangement of lots of those added together. So it's not that complicated really, but we can plug the numbers into this now to find an estimate for the area. So we can say the area will be half the height. Now remember the intervals of x are going up by a half, so a half of a half is a quarter, multiplied by y0, which was 3, plus 2 times y1, which is 2.3041, plus y2, which was 1.9242, plus y3, which was 1.9089, and then we need to add the last y value on the end, which was 2.2958. So we plugged everything in now, we just need to enter that into a calculator. So let's put all of this in as it is, so 0.25 or a quarter multiplied by 3 plus 2 multiplied by 2.3041 plus 1.9242 plus 1.9089, and then we need to add that last y value on the end, which was 2.2958, and that is all multiplied by a quarter. And just check we've entered it all correctly. You never want to make any mistakes when you're entering things in a calculator. That's the easiest way to lose marks and the most easily avoidable way to lose marks. So all of that is entered correctly, and we get an answer of 4.39255. And we need that to 3 decimal places, so this is going to be 4.393. So that's our estimate for the area, and they haven't given us any units, so we can just leave that as 4.393 using the trapezium rule. Okay, part B says, explain how the trapezium rule could be used to obtain a more accurate estimate for the area of S. So if we were to estimate this more accurately, we might split it into smaller increments. So there are more little trapeziums we break this up into, and so the increment of the x values would be smaller. So we might go up by a quarter or something even smaller than that. So we can just say something like add more intervals between x equals 1 and x equals 3, or however you want to word that, as long as you're indicating that you're splitting this shape up into smaller areas and then adding them together. Okay, part C says show that the exact area of S can be written in the form a over b plus the log of c, where a, b, and c are integers to be found. And it says in part C, solutions based entirely on graphical or numerical methods are not acceptable. So that is clearly telling you need to take the integral of this equation, and this is going to require us to use integration by parts for this x squared log of x. Now if you haven't done integration by parts yet, you probably won't understand my explanation. Absolutely feel free to watch my explanation, but just be aware that you need to go away and do some research on integration by parts first in order to fully understand it. So Let's go ahead and get started on part C. So we need to take the integral of this equation. So let's start off by writing that equation down again. So y equals x squared ln x all over 3 minus 2x plus 5. Okay, so to find the area of S, we are going to need the integral of all of this. So x squared ln x over 3 minus 2x plus 5. And remember the rule for integration by parts. It says that the integral of u dv equals uv minus the integral of v du. And we can use that rule to find the integral of x squared ln x. This 2x plus 5, that won't be a problem. So let's just do that quickly first. So the integral of minus 2x plus 5, that's just going to be minus x squared plus 5x plus c. Remember, always adding that constant on the end. Remember, the coefficient becomes a power and we divide by the power of x, which was 1. So no problems with that integration. But now we need to worry about this integral of x squared ln x, and I'm just going to write it as a third x squared ln x instead of x squared log of x over 3, because when we have that constant we can just put it outside of the integration, it won't make a difference. So next line, we've got a third integral of x squared log of x, and now we need to decide which values we give to u and which values we give to the derivative of v. So in this case, there's a rule of thumb saying that you give the value of the derivative to the one you think is easiest to integrate. So in this case, I would say the x squared is the easiest one to take the antiderivative of. Remember, the antiderivative of log of x is x plus the log of x plus c. And when we take that antiderivative, you're still left with a log in the answer. So what we want to do is to let u equal the log of x and the derivative of v equal to x squared. And now the derivative of u is just 1 on x. Not too bad, that could be easy to work with. And the antiderivative of dv is x cubed on 3. Okay, so you can see that we're not left with any logs in the derivative or antiderivative, and that means that it's probably going to be easier to deal with. Okay, so we've said that u is the log of x and dv is x squared. So the integral of u dv is uv minus the integral of v du. Also remember, we've got that third out the front. So this is going to equal u. Now remember that u is the log of x and v is x cubed on 3. So this is multiplied by x cubed on 3. And then we need to subtract the integral of v, in this case is x cubed on 3, and du, which is 1 on x. So that's multiplied by 1 on x. Oh, and that third is multiplied by everything here, not just the first term. So we've made some progress. So on the next line, let's simplify this a little bit. I'll still keep the third out the front. So here we've got x cubed log of x on 3. And now let's have a look at this integral. Firstly, we've got an x on the bottom line and an x cubed on the top line. So we can cancel one of those x's. So that becomes x squared. So we want the integral of x squared on 3. And we know how to do that. Remember, we add 1 to the power and we multiply the denominator by the power plus 1. So the power is going to be on 3 and we multiply the denominator by 3. So this, on the next line, we've got a third multiplied by x cubed log of x on 3 minus x cubed on 9. So 3 times 3 is 9 there. And then we just need to distribute that third to both terms. So we've got x cubed log of x on 9 minus x squared on 3 times 9 is 27. Okay, so we have found the integral of a third x squared log of x, and so let's just write it all out in one line. So the integral of a third x squared log of x minus 2x plus 5 is going to equal x cubed log of x on 9 minus x squared on 27 minus x squared plus 5x plus c. And now we want to use this integral to find the area under the curve, that area S from the graph. And here we can use the fundamental theorem of calculus, which says that the area under a curve equals the integral at B minus the integral at A. So we can take the value of this integral at x equals 3 and the value at x equals 1 and subtract those to find the area. So we usually write that in square brackets. So we can write out that whole thing again. Minus x squared over 27 minus x squared plus 5x. And now we don't need to worry about the constant because we're talking about a discrete integral between two values. So when it's discrete, we don't need to worry about that constant. And it's going from 1 to 3. Oops, sorry, I've just noticed a mistake. This is meant to be a cubed. I've just made a small error there, so sorry about that. A cubed there, and a cubed here, and a cube down here. Again, I apologize. So that's a cubed. Okay, so continuing on. So we substitute 3 into this, and substitute 1 and subtract them. So if we substitute 3 in, we're going to get 3 cubed, which is 27, and the log of 3 over 9, minus 3 cubed again is 27 on 27, well that's just going to cancel to 1, minus 3 squared, which is 9, plus 15. So that's when we substitute 3 in, and then we subtract when we substitute 1 in. So 1 cubed is just 1, and then the log of 1 over 9, minus 1 cubed, which is 1 over 27, minus 1 squared, plus 5 times 1. Okay, continuing on to the next page. So 27 over 9, that can cancel to 3, log of 3. Minus 1 minus 9 plus 15. All of that is going to evaluate to plus 5. And then we subtract all of this. So the log of 1 is just 0, so effectively that cancels itself out. Then we've got a minus 1 on 27, minus 1 plus 5. So I'm going to write that as minus 1 on 27 plus 4. And then let's expand this negative out to all of the terms inside those brackets. So we've got 3 log of 3 plus 5 plus 1 on 27 minus 4. And then plus 5 minus 4, that's going to be plus 1. So we can write this as 3 log of 3 plus 1 plus 1 on 27. And then we need to combine this 1 and this 1 on 27. So 1 can be rewritten as 27 on 27 plus 1 on 27. That's going to equal 28 on 27. And also we know that when we have a coefficient of a log, that can be raised to the power of the number inside the log. So we know that 3 log of 3 also equals log of 3 cubed, and 3 cubed is 27, so this can be written as the log of 27. So this expression can be rewritten as 28 on 27 plus the log of 27. And remember, we needed it in the form a over b plus ln c, and we need to find the values of a, b, and c. So let's go back to our final expression here, and we can say that a equals 28, b equals 27, and c equals 27. Okay, so that whole question was for 10 marks. So question 14 was 10 marks, and let's just quickly look at what each question was worth. Part A was 3 marks, Part B was 1 mark, and Part C was 6 marks. Question 15 gives us a graph called Figure 5, and it says Figure 5 shows a sketch of the curve with equation y equals f of x, where f of x equals 4 sine 2x over e to the power of root 2x minus 1, where x is between 0 and pi. And it goes on, the curve has a maximum turning point at P and a minimum turning point at Q as shown in figure 5. Part A says show that the x coordinates of P and point Q are solutions of the equation the tangent of 2x equals root 2. Okay, so we've got turning points here of a function, and usually to find where the turning point is, we need to take the derivative of the function and find where the derivative equals 0. Remember, at the turning point, the gradient is 0, and so the derivative will be 0. So what we want to do here is to find the derivative of this function, make that equal to 0, and then try to solve it or rearrange it to get the tangent of 2x equal to root 2. So let's start by finding the derivative of this equation. Okay, so for part A, well, let's state our reasoning. So we can say the turning point will occur when f dash x equals 0. So let's write down the function down here. So f of x equals 4 sine 2x over e root 2 x minus 1. By the way, if you're confused as to whether that's root 2 or root 2x, you can see that the square root symbol clearly cuts off over the 2. So if this was the square root of both the 2 and the x, that would continue on. So just in case you're confused by that. Okay, so now we want to find the derivative of this function. We are going to need the quotient rule because we have a variable on the top and bottom line. So remember, the quotient rule says that f dash x will equal v u dash minus u v dash over v squared, where the top line we let equal to u and the bottom line is v. Okay, so we just need to write this out with all of the variables in the correct places. So v is e root 2 x minus 1, so that comes first on the top line, e root 2 x minus 1, and then the derivative of 4 sine 2x, we need to use the chain rule for that because we have a function inside of the sine function. So we can say the derivative of 4 sine 2x is going to be the derivative of sine multiplied by the derivative of 2x. And remember, we can effectively ignore that constant out the front, so that just stays where it is. And then we multiply by the derivative of sine of 2x, which is the cosine of 2x, multiplied by derivative of 2x, which is just 2. So this becomes 4 cosine 2x, 2, which is 8 cosine 2x. Okay, so that's u dash, so we need to multiply that by 8 cosine 2x, minus u, which is 4 sine of 2x, multiplied by v dash. Now the derivative of e root 2x minus 1, again we need to use the chain rule. So the derivative of e root 2x minus 1, well, the derivative of e is just itself, so that stays as e root 2x minus 1, and then we need to multiply that by the derivative of root 2x minus 1, which is root 2, and that is all over v squared. So I'll just write that as e root 2x minus 1 all squared. Alright, and now we're going to be able to simplify quite a bit when we let all of this equal to 0. So again, let's just state that the min and the max occur when f dash x equals 0. So all of this equals 0. So therefore e to the root 2x minus 1 multiplied by 8 cosine 2x minus 4 sine 2x multiplied by root 2 multiplied by e root 2x minus 1 all over e to the root 2x minus 1 all squared equals 0. And now because that equals 0, that allows us to multiply both sides by this denominator, effectively cancelling it out. We can also factorize an e root 2x minus 1. So if we factorize this e root 2x minus 1 out of both terms, we could then divide by e root 2x minus 1. and that cancels that out. So on the next line, we can say, therefore, 8 cosine 2x minus 4 sine 2x times root 2 equals 0. So that's allowed us to simplify quite a bit. And then what I want to do is to take this minus 4 sine 2x times root 2 over to the right hand side. And this will make sense in a minute, but let's rewrite this as 8 cosine 2x equal to 4 root 2 sine of 2x. So that becomes a positive when we add it to the other side. And now what I want to do is to have on one side sine of 2x divided by cosine of 2x and all of the constants on the other side. Because remember that sine of anything divided by cosine of that same thing equals the tangent of that variable. And remember, we're looking to rewrite this equation as the tangent of 2x. So if I can get the sine of 2x divided by the cosine of 2x, that will allow me to get the tangent of 2x. So let's rewrite this with the sine of 2x divided by the cosine of 2x on the right hand side. And then also we can divide by 4 root 2 on the left hand side. So on the left hand side we'll be left with 8 over 4 root 2. And on the right hand side we'll have the sine of 2x divided by the cosine of 2x. And I'll just flip this around so that the tangent is on the right hand side. So I'm going to change that to the tangent of 2x equal to now 8 over 4, that can cancel to 2 on root 2, so this becomes 2 on root 2. And now you're wondering, well, this isn't root 2, but remember that 2 on root 2, if we multiply that by root 2 on root 2, which is just multiplying by 1, so we haven't changed anything, that becomes 2 root 2 over root 2 times root 2 is just 2. Those 2's cancel out, and so this just equals root 2. So 2 on root 2 is the same as the square root of 2. So therefore we can just say that the tangent of 2x equals root 2. And therefore we have shown the turning points when the derivative of f of x equals 0, when the minimum and maximum occur, the tangent of 2x will equal root 2. Okay, so that was for part A, that was 4 marks. And then part B says, using your answer to part A, find the x-coordinates of the minimum turning point on the curve of the equation y equals f of 2x and y equals 3 minus 2 f of x. So that's saying we need to take this function but change the variable and multiply it by 2. So you need to think, what effect would that have on this function if we multiply this input by 2? Well, changing this input by doubling it would probably affect the period, so this turning point would end up being out here somewhere. But that's not really what we want to worry about. We want to worry about how changing this input would affect f dash of x. So how would it change this answer down here, this tangent of 2x equal to root 2? And if you want, you can substitute, instead of x here, substitute 2x in. So you'd have f of x equal to 4 sine of 4x divided by e root 2x minus 1. And you can take that derivative again and so follow all of the steps. So here you'd have a 4x and you'd have a double this, so 16, and then you'd have a 4x here. And you can follow all of these steps again, and you would find you'd end up with the tangent of 4x equal to root 2. So that's the only difference we really need to worry about. So for part B, we can say that the minimum of y equals f of 2x occurs when f dash 2x equals 0. And so we can say, therefore, the tangent of 4x equals root 2. And you can just think about that logically. If we're substituting in the input multiplied by 2, all we really need to change is this input of the tangent. So now we need to solve this. The tangent of 4x equal to root 2. So therefore, 4x will be the inverse tangent of root 2, or you might see that written as arctan. That's the same thing. So arctan and the inverse of the tangent are the same thing. And so therefore 4x equals the inverse of root 2. So let's put that into a calculator. Remember that for this question you need your calculator in radians because we're talking about functions with respect to pi. So we need the inverse tangent of the root of 2 in radians. So this is going to be 0.9553 radians approximately. And then to find x, we need to divide that by 4. So x is going to be that divided by 4. So the answer divided by 4, which will be 0.2388 approximately. And then we need to add on the period of the tangent function. So the period of the tangent function is a quarter pi, because effectively we're solving a wave, if you like, following the tangent function. And the minimum and maximum, there's not going to be just one, there's going to be a number of minimum and maximum on this wave. So we are solving all of these values. Now the first one will be this value, but we need to add on that period of the tangent function to account for all of the minimum and maximum of this wave. So we need to add on that period, which is pi on 4, multiplied by the integers. So k standing for the integers. And now we need to think critically for a second. We need to go back to the graph of this function. Now remember, the maximum was the first value on this graph, and we are looking for the minimum turning point of f of 2x. Now this wave has not been reflected. If we change that input by multiplying it by 2, this wave is still going to look very much like this. Now the period might have changed a little bit, but the maximum still comes first. The maximum is still the first turning point. So we want the second turning point of this function. So that's going to be the second value of x, where there is a turning point. So that's going to be 0.2388 plus pi on 4 times 1. So the second turning point. Remember, this is the first turning point, so we add pi on 4 to get the second one. So we can say the x minimum will equal 0.2388 plus pi on 4. So the second turning point, if we put that into a calculator, so take the answer and add pi on 4, and we get 1.024 approximately, 1.024 to 3 decimal places. Okay, so we have the x value of the minimum when y equals f of 2x, and now we need to do y equals 3 minus 2 f of x. Okay, so how would that affect the graph? So this is part 2, y equals 3 minus 2 f of x. So let's look at the graph and think how that would affect it. Well, that 3 is going to shift the graph up. So any constant will shift this graph up 3 units. But that wouldn't change the x-coordinate of the turning points. The x-coordinate of the turning points would still be the same. So that's not really going to change anything, that 3. So let's pretend the new midpoint is here. So the x-coordinate hasn't changed by that, but this minus 2 will affect the amplitude. It will also reflect the graph in the x-axis. So the graph is now going to go down and then up and then flatten out. So because it's become a negative, the coefficient has become a negative, so we reflected it in the x-axis. The amplitude will be affected by that 2, but again that won't change the x-coordinate of the turning point. However, the new minimum will be the first turning point, not the second turning point. So we are looking for the minimum turning point, and now that's going to be the first x value of this graph. Okay, so I hope that makes sense. In effect, we've reflected the graph, so now the first turning point is the minimum, not a maximum. Okay, but everything else has stayed the same, so the x values will still be at the same points. It's just that we're not looking for the second x value now, we're looking for the first x value. Okay, so we can effectively solve tan of 2x equal to root 2 to find the x value of the turning points. So let's just write some of that explanation down to make it clear we understand what's going on. So I'm going to write a bit of a paragraph here, and then I'll read through it. Okay, so when y equals 3 minus 2 f of x is reflected in the x-axis and the amplitude changes, but the period is unchanged, meaning that the x value for the minimum will be the x value of the maximum of f of x. Therefore, the minimum occurs when the tangent of 2x equals to root 2, just as we said in part A. So therefore, 2x equals the inverse tangent of root 2. So again, let's just find this again. So the inverse tangent of root 2 is going to be 0.9553. So x equals that divided by 2 this time, which is 0.4777 rounded off. And because we're talking about turning points, we need to add that this will be x equal to 0.477 plus pi on 4 times k. But we're looking for the first minimum, so we can say x min equals the first turning point, which equals 0.4777 to 4 decimal places. So there's a little bit of reasoning in that last part of that question. I hope that all made sense. I tried to make it as clear as possible, but you just need to think about what changes this makes to the function f of x. So when we have that 3 minus 2 f of x, what does that do to the graph, and how does that change how you find the answer? Okay, so that total question was for 8 marks. Let's just go back to the marks again. So part A was 4 and part B was 4 marks. And that's the end of this paper. I hope you found that useful. This was my first walkthrough of an A-level exam, so I'd be curious as to what you thought. Please let me know in the comments. Leave a like if you appreciated this video. Also subscribe if you want to see more content, and I'll see you in the next one. Bye for now.